Okay, so today we're going to do a recap of the functions and the mainly the variable scope. Okay, I think some people have trouble with variable scopes, so I'm going to go over variable scopes, what they are, and the lifetime of a variable. Okay, so remember I said global variables are also bad, right? So we're going to find out why. So let's say I have a function. Um, Takes in two variables a, b, and I'm going to return a plus b. Okay, and then I have another function called function 2 ab that's gonna return a times b. Okay, uh, now if I define x here be 2 and y to be 2 or 3 just to make it interesting. Now suppose I call function with xy, right? um, and assign this to a variable called r1 and r2 to function 2 and passing in again xy, right? um, so so what is actually happening here when I define these variables? Let's just draw a picture. So what is happening is actually I'm creating a label. Okay, here I created x. When I say here at this point x equal to 2, what happens is I create an x, a label, and in fact like Python creates me 2 in memory. Okay, and it's actually has a type to it as well. Remember, the whole numbers are integers, so this is an int 2, and in fact this integer is actually an object. Everything in Python is an object. We will get to what object is, but just think of it as every variable, everything that we assign, everything that we work with are objects. Okay, so we create, so x equal to 2 basically means I have a label. I created x. Oh God. X, that's actually pointing to this object called integer 2. Okay, value 2. Same with y. So if I say y, integer 3 object, and it's pointing to this. Okay, now when I pass in x and y to this function, right, I'm passing x and y, but inside the function I have these a and b, right? So what will actually happen? A and b are actually also something like this, x and y. Okay, so as soon as I pass the parameters x and y to the function, inside the function is when these labels get created. Okay, so a will be pointing to x. Okay, and sorry, b will be pointing to 3. Okay, that's exactly that basically what happens. Okay, so now within this, when I say a plus b, I am actually referring to the same one, x and y, but I have a new label to them. Okay, you can think like a label. Now suppose in here, let's say if I say a equal to a plus 1, what do you think is actually happening? So a is a plus 1. Right now a is pointing to 2, and as soon as I say a plus 1, Python is going to actually create me another object, integer, where 2 plus 1 is 3. Okay, and now this reference is actually gets pointed back to here. Okay, but remember x is still pointing to 2, but whatever I do inside is I'm just referring that label a to something else. That's what's happening. Okay, now when I return back a plus b, Python actually figures out, okay, a is pointing to 3 and b is pointing to 3. When it returns back out to R1, and Python creates so as a new object where the value is 6. Okay, int 6. Okay, so this is what's actually kind of happening. Okay, so now R1 is 6, but notice that x and y are still 2 and 3. Okay, and this a and b no longer exist after I call function. Okay, it's only visible or only kind of alive within the function scope. Does that make sense to everybody?
Yes.
Okay, so one thing to keep in mind is that I won't have access to a and b here. Let's say if I print, let's just run this program, see what's happening. Okay, I haven't printed anything out, so nothing prints. So let me just print out R1. R2, run this. So it just prints 6 and 6 because I'm just adding 2 plus 1 is 3, 3 plus 3 is 6. Here, this one is 2 times 3. So let's just change this to 4, so we have a different number. So 7 and 8, okay? So if I, at this point here, when I say print A, there's no A. The A is only visible within this function, okay? So that's something to keep in mind. Okay, it's going to complain. Name A is not defined. It's only that variable is only alive within that function. And this A has nothing to do with this A in another function. These are two separate ones. Okay, so when I call function 2, passing in x and y, let's go back to our diagram. So remember that function already completed. So this A and B are gone. Okay, that A and B are gone. We have R1. Okay, now what happens is that R for this function called function 2, same thing happens. X and Y gets passed as A and B. So this A and B is a new A and B. A and the value is 2. It's referring to 2 because X is 2, and then Y, we change this to 4, sorry. B is pointing to 4. Okay. Now suppose I do something else, like I do here. The same thing will happen. Say for example, let's say A equal to 8 times 2 or something. In this case, what will happen is it will say Python will say A is 2 and 2 times 2 is 4. So it will create me a new object. Okay. Here it will be int 4. And this reference gets changed because I'm assigning the result of 8 times 2 to A. So that's no longer, that A no longer points to no longer points to that original parameter that we passed. It's pointing to something that we calculated up here. Okay, B is still, I haven't changed B yet. B is still pointing to 4, and the result Python calculates 4 times 4 is 16, and it's going to return back and assign it to variable r2. Okay, so here we create another variable r2, and that gets assigned to the result, which is another object that gets created, which is 16, right? And that's where r2 is pointing to. Okay, now these are like basically memory in the computer. Okay, but they are called objects. Okay, we'll get into objects later, but for now this is the way to think about it. Okay, and soon as we come to r2, the function 2 completes, so no longer the a and b that was declared here, they don't exist anymore. So those things just go away, these labels. Okay, and this intermediate object that gets created up here, that's also gets basically garbage collected by the Python interpreter or Python runtime. Okay, so this is what we end up with after everything is executed, after function 1 and function 2. Okay, so we only have 4 variables, x, y, r1 and r2. So all these intermediate ones, they just go away. Okay, is everyone clear on that? Because I think when you try to create these functions, you think that the variables are still existing, but they don't exist. Okay, so the way to think about functions is that functions should only deal with whatever you pass in, right? That's the only thing that is visible to them, and what you get back is something that you can assign somewhere. Okay, so don't try to change something like we'll find out. So so for example, okay, that's one thing to remember. Now let's look at something else. Remember, let's say I have a variable x equal to, I'm going to call this global. Okay, global x. Okay, so this is a global variable, and if I have a function can I say x, because remember I'm not passing in a parameter to this function. Okay, can I say x equal to 5 here? Remember, x is not something defined inside the function. Now if I call this function and then I print this x, let's just make this a string. Let's say I'm gonna assign something. Okay, local x. Now can I do, what do you think the result of printing this x would be?
Global x?
Yeah, basically this x, if you see the squiggly line here under the x, it says that shadow name x from outer scope and says local variable x value is not used. Okay, so one thing to note is that if you have a global variable outside, you should never use that name inside the local variable, because global variables are bad. And what will happen is, when you might think that you're actually changing the global variable when you say x equal local x, but what will happen is indeed you'll just print global x. So from within the function, if you try to access a global variable and try to change it, nothing gets changed. It's just only a local variable, a copy of a label called x is created inside the function. Okay, so accessing global variables within a function, it's a bad idea. Okay, the intended effect that you're hoping for is not going to happen. So that's what we mean by this. This x is actually a local scope. It's in a local scope for that function. Okay. So another thing is, we talked about, so let's say if I define y, local y, and that y won't be available outside. It's just with only the lifetime of that variable y is only within that function. Okay. what else? So changing, but the funny part is that if I print x from within the function, you can still access that x. So if I run this, it's going to say global x. You can still see the x if you don't define it to something else. You can still see it, but changing that value is kind of a no-no. You don't want it. It won't change it outside. It'll just create a temporary variable, a temporary, like a shadow variable. That's what's called. Okay, so don't even go into that. So like you just want to avoid going into that. So you always make sure that you pass it. So if I want to do something with that variable, pass it as something. Okay, and always make sure to give it a different name than the global variable. Because if you say x, and in here you pass an x, it's the same thing. You see, it says shadow variable x. Okay, so just name it differently so you know that you're dealing with a local variable. And when you pass the x here, let's say I do something here. Let's say a equal to a plus 1. Let's print, I don't know, just for sake. And if I run this and I try to print x, sorry, not a plus 1. Let's say, okay, let's just change this to 1. Okay, if I run this, inside it prints 2, outside is still 1. Okay, so in order, like the convention is that you don't want to. There's also another scope called um, I forgot what is it scope. It's basically it's a little bit more advanced. So you can have functions within functions, and they're a little bit more advanced. So we don't need to learn about that. But for now, you can just think about two scopes: global and local. Okay, and local is only local to that function, and global can be read by the local function, but we don't want to do that. Okay, and if we want to, we always pass it as an argument, as parameter. Okay, and a variable within one function is not visible to another function somewhere else. So everything is local to that function. The only way that you can return something from that function is by returning a value. Okay, what else did I want to say? Oh, another thing. Okay, let's say like this. Let's say I have a function, and let's say I have a if block. I'm just gonna make it true, because, and in here if I say y, or any variable y equal to block scope, I'm just gonna say this. So if I declare a variable here and I come out of the if, I still have access to that y. Okay, that's kind of weird. You probably don't want to do this, but I'm just saying that you still have access to that y within that function. We're still in the function. You see, the indentation tells you that we are still in the function. Okay, so if I print this, if I run this, it's still gonna say block y, even though we only define this variable within that block, right? In other programming languages, you won't be able to see it, but in Python, anything that you create in a function, it's available to any subsequent statements within that function. Okay. What else did I want to say? Yeah, that's about it. So those are scopes. Any questions so far? Everybody's crystal clear on that? Okay, so in another thing is that in Python usually you don't like, for only for learning purpose we created these variables in global scope, but most of the time you won't be creating it. So the convention is you create a uh, function called main. Okay, this is just a convention. Okay, and you do whatever you do in here. So you have a local, let's say local x. Okay, this is kind of your global x. So you have this function main, and then you define all your variables in here. And let's say you wanted to call another function. Let's just make this one. Okay, so let's say I have a function called add ab. Oh, let's make it xy, because we don't have any other functions defined as xy in that global scope, so it's okay to create it, right? We won't complain. So here I return x plus y, and in my main I have x, y equal to, and if I wanted to calculate what add function does, so I can just print add x, y. Okay, and all I have to do is I just have to call main. Okay, this quickly part, okay, we'll come to that. This part here, this if statement, we'll come to that later, but for now we can think of it as like this, main. We just call main like that. So if I run this, I don't have any global variables, but I still have the same effect. Does that make sense? You see how I didn't? So everything is within my main method. I create everything and I just call that main method. So basically what you used to do, this thing in the global scope, what you're now doing is you have a main method and you do everything in that, and then you always call this main method. Okay, so this way you don't have to think about global variables. You don't have to deal with them. Okay, so your all your functions will be strictly deal with input and output. It won't be accessing something that is not passed as an input. Okay, that's just a best practice, because if you think about it, if you have a big program and you have many functions, and if function starts changing the global variable, uh, you don't know, you can't keep track of which function is actually modifying your variables in what way. If you just have just the function deal with only the parameters that is passed in and returned, then anywhere within your program, if you just look at that we look at that function, you can exactly tell what's actually happening in your program. It's just the function call. Whatever you pass to the function, it's going to do something and return back. Krishna, are you sleeping? Okay, does that make sense? Vaishnav, Inya, are you following Inya?
Yeah.
Okay, just pay attention, okay?
Okay.
Okay, so far, okay, that's about it for scopes. Now, regards to remember I said you can only return one thing from a function, and suppose we wanted to return multiple things. How do we go about doing it? So in Python there is another type. There are many types, built-in types, but we're just going to go one by one. So far we looked at integer, float, right, which is the decimal, and then we looked at boolean, right? There's another type called it's called tuple. Okay, so tuple is basically like this. You put it in a bracket, and you can have a comma separated list of values in it, but it's still considered as one variable. Okay, so let's say for example I can call this variable, let's say uh, let's say Bob. Okay, so this would have Bob first name to be this first parameter, and last name would be, I don't know, something like this. Okay, so now Bob is actually a tuple type. It's not an integer, no, it's not a string or anything. It's just a tuple. It's a special type where this brackets denotes that this whole thing is to be treated as one variable. And it's not just limited to 2 items. You can have many items as you want. Let's say, for example, let's say I want to capture the age or something. All this is treated as one variable. So in the memory, if you think about our diagram, so here Bob is actually an object that has 3 things: int, or sorry, string, string Bob, that's the first one, and string do, and then also an integer 30. Okay, so this is what actually this Bob label is actually pointing to. So this is still a variable, okay, but the type is a tuple. Okay, right now it contains 3 separate values. Okay, what we used to have it as separate variables, we can put them all together in this new type called tuple. And tuples is not restricted to just 1, 2, or 3, right? It can be in any number. Okay, so now if we go back to our function, let's say as an example, let's say I wanted to create a function where it calculates area of a rectangle. Okay, so I can say calculate rect area, and I pass in 2 sides, length and width, and the area would be L times W, right? That's the area. Now if I have another function that calculates the perimeter, rect perimeter, if I give length and width and I want to calculate the perimeter, I will say I will return, what's the formula for perimeter of a rectangle? Anybody?
1 times 2 plus width times 2.
Yeah, so I can just say something like this. Okay, oh sorry, you can't type. Okay, is that also correct? 2 times length plus width. I have it in a bracket. Okay, so the bracket, in Python is still the same thing. If you have an expression, it still calculates it as per bedmass, but you have to specify the brackets yourself. Okay, so now going back to our tuple, now if I wanted another method saying calculate rectangle info or something, and L and W. Now if I wanted to return both the area and the perimeter, now I have a way of returning it. I just have to return like this, something, the let's say the first part of the tuple is the area, and the second one is the perimeter. I just make it variable, area and perimeter. I can do this. So all I have to do is I have to create a variable area and say calculate rect area, pass in length and width. Now I have the area and perimeter. Actually, in fact, the parentheses is not really needed. It's the comma that's what's going to make it a tuple. So I can say area and perimeter. Now in my main method, yes, just follow what I'm saying, okay? So now in my main, I have a rectangle. So length equal to 10, width equal to 5. Now if I wanted to calculate the information about this, say rect, I create another variable rectinfo and I call calculate rectinfo length width passing in. Now this rectinfo variable that I created will have it won't be just one value, but it will contain two values, which is a tuple. First would be the area and the second would be the parameter. Okay, if I just print it out, we'll just run that. See, so area is 50, like 5 times 10 is 50, right? And then the parameter is 30. 10 plus 5 is 15, 15 times 2 is 30. Okay, that's what a tuple is. That's how you can return like more than one value out from a function. Everybody clear on that? See, I just wanted to show you that how to break something, a function, into multiple calls. Okay, and return a. I still have access to being able to calculate just the area or the perimeter because I have that function. I have the ability, and I can also do them together if I need those two information, right? I think I should call it length, or call it length. Length is also built in. Okay. So another thing to look for is this. You see how it still says shadow built-in name length. So there are Python has a whole bunch of uh, built-in functions for us, right? So for example, that print function, it's a built-in one. So whenever you name your variables, the IDE or PyCharm will warn us that if we try to name it to something that already exists within the built-in functions, it'll say, okay, just change that name, because that's probably a collision between the built-in name and the one that you are creating, the variable name. So in this case, let's say I say a b or a width or something like that, and b width something. Okay, that's something to keep in mind.
Is it an A line?
Oh yeah, sorry. Yeah, you always want to name your variables in a meaningful way. So yeah, and also even here, it's kind of complaining. Okay, here. Oops. So anytime you see these squigglies, that means something, you have done something wrong, and you better try to fix them. Okay, so that's a new type that we learned. It's a tuple. Any question on this new type tuple, and when we
How
would
would
use?
we get rid of the brackets?
What is that?
How would we get rid of the brackets in the console?
Oh yeah. So right now I'm just hello. Yeah, sorry. So right now um, we just print out the variable, right? Rect.
You're muted.
You're muted. Muted. Ads came muted you.
Oh, okay. So right now we just print out the variable rect info, right? So by default, when Python prints a tuple, it always puts it in a bracket. Okay, so if I just wanted to print out without the thing, without it, I will have to have a new notation. I have to put it. I have to identify the things, the first one and the second one like this. I have two square brackets, and I have to put a variable. Oh, sorry, a number. It's an integer number that says it's 0 base. So 0 is actually the first one, and 1 is actually the second one. So if I print it now, you're actually getting the first one out of this rect info, and the second one like this. Okay, so this is another new thing that we're learning. Okay, so 0 is the first one and 1 is the second one. So the first element always starts with 0.
Shouldn't it be 1 is the first one and 0 the second one?
No, first one is the 0.
Why? Why?
It's a convention in programming where the index always starts with a 0 for any kind of these type of collections. The tuple is also it's called a type of a container or a collection. Okay.
Can the 1 be a 2-digit number? Can that 1 be a 2-digit number?
No, it cannot. Well, yeah, it could be 2-digit because it depends on how big is your tuple is. Right now, our tuple is only 2 elements. It only has 2 elements. But as I showed earlier, the tuple can contain 3, 4, as many as we want. Okay, and the memory representation, it'll look something like this, a tuple. Okay, so this is what we mean by everything in Python is an object. Kind of. Okay, any questions? Any other questions on tuple? Okay, so let's go into let's create and let's ask ourselves. So we learned about string, integer, float, boolean, and now tuple. We're going to look at another one called a list. Okay, so list is another built-in type from Python. So the use case, or when we would use a list, suppose I ask you to write me a program where you're going to keep asking from the user a list of numbers. Okay, and you want to store that list of numbers in your program, because I'm going to ask you, okay, find me all the, let's say for example, so you're going to get a list of numbers from user, and you're going to increment all the numbers by 1. Okay, suppose if I ask you, how can you capture all these numbers that, so let's say while true. Okay, I'm going to ask for a number, say n, just say it's an integer. Okay, so int input. Okay,
Def. You put def there?
no, I don't have a function. I'm just writing something. Yeah, but we should have it in a def function, as Arjuna is saying, because we don't want to use anything in the global scope. But just for our illustration purpose, I'm just going to say this. Okay, so we take an input. By the way, the input function, we can also pass in something like as a string here. It's called a prompt. So let's say I'm going to say enter a number. Okay, this is the same thing as I'm printing it and then I'm asking for it. Okay, this input function can do that. Okay, this is another way. So if I say this n, and I want to keep asking the user for as many n as possible, okay, until he types in let's say -1. Okay, so how can I keep all these numbers that the user types in a variable? It's a problem for us, right? Because how do I know how many numbers he's going to ask? Like if I know that he's going to I mean, how many numbers he's going to give in and type in. Let's say if I know upfront that it's going to be like 2 numbers, I can say a equal to, I can just initialize the variable b equal to 0, and I can say first one is a and second one is b. You know what I mean? But if I have an unknown number, basically a list of numbers that the user is going to input, I don't have a way right now of storing those in a variable, right? Because I would need to create as many variables, because I don't know how many times this guy is going to enter, right? You know what I mean? So that's where a list variable comes in and helps us. So 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 the list is like this. Let's say I call this list 1. So it always starts with the square bracket. This is how you like initialize a list. And I can have similar to tuple, I can have any number of elements and it's separated by commas. Okay, so if I want to have a list of numbers 1, 2, and 3, I can do this. I can have any number of basically these are called items in the list. Okay, now list has a list is an object similar to tuple. So in list you can do things like this. For example,
Print out.
let's just print first and just see the output.
It says out.
Yeah. Oh, sorry. Wrong one. Okay, so that's how it's going to get printed. Tuple prints out with the brackets. This one is a square bracket. Okay, so when you see a square bracket, you know it's a list. So list 1 is actually a type called list, and it's a list is an object. Okay, so in memory representation it would look something like this. So I would have a label list 1 and it's an object and it contains int 1, int 2, int 3, int 4. Okay, right now this is how it looks. Okay, so beauty of list is that I can add stuff to the list. So here this one we haven't seen this before, obviously. So if I say list 1 and I put a dot, like a period, it'll show me a list of functions that I can call on this object list 1. Okay, this is something new. Before we had an object like a int, float, and stuff like that, right? We never said like let's say a variable a dot. This is something that you can do with an object. Okay, so you can say list 1 dot and it shows you a list of, these are called methods, but basically you can think of it like a function that 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 executes on this object. So you can see that it always, the first parameter is self, right? So that's a hint that this function has access to this list 1 contents implicitly. So if I say list 1 append, and I put 5 in here. Okay, so first let's just print this. Print list 1 list print list 1, and I just run this. You can see what happened, right? So when we call this method list1 append, passing in 5, it got added to the end of that list. So now list1 not just contains 4 items, it has an additional item that we passed in using the append method. Okay, that's how we can grow this list. That's why it's called the list. Okay, so in our memory representation, so when I did list1 dot append 5, this memory actually grew by another 1 element. Okay, this is what happening. So it can just keep growing. I'm sorry. How to make it bigger? Yeah, it can keep growing and shrink. So it's kind of like a dynamic, stretchy thing. If you visualize it that way. Okay, that's one way to visualize. Okay, so now going back to a problem. Let's say I want to collect a list of numbers from the user. I can initialize a variable, empty list. Okay, this is how you create an empty list. And now I can say while true, let's say n equal to int input, enter a number, or -1 to quit. Okay, let's just say it like this. So now I ask the user continuously for a number. So when I have a number, now I have a number n, I can say list1 append n. Okay. Now another thing that I didn't teach in the loop is that whenever we want to exit this while, remember we always had a condition, right? Another way to exit out of the loop is with another keyword. So if actually we want to exit if the user says -1. So if n equal -1, if I say break, okay, it'll basically exit out of the loop. Otherwise it'll just continue again and again. Okay, that's another way of getting out of the loop without, if you don't have a conditional variable. Okay, this is it's another way to get out of the loop. Okay, this basically it kind of overrides this condition and gets out. Okay, anyways, so that's just one way. So let's focus on the list. So now if I just want to print out, if I print out the list now, the list will contain all the numbers that the user inputted. Okay, so let's just run that program. Enter a number. Let's say I put 1, 2, 3, 4, 5, 10, -5, -3, -5, whatever, right? And I press -1, it'll exit out, and I will have that list. You see that? So now I have in my memory, I have a variable called list, which it is of a type list, and I have all these numbers inside the list. So that's what the list type gives us. And list type, it doesn't have just the append method, it has many methods. So if you look at it, so it has another key important one is, let's say if I want to set some so right now I have 1, 2, 3, 4, 5, 10, 35, right? Okay. Let's just write this thing in our wrapper so it's easier. So let's say I have a list which is equal to 1, 2, 3, 4, 5, Okay, so I can do list append, let's say 6. If I append 6, the list is, you can see on the left hand side, list expands, and I have many methods. So another thing is, if I want to reassign, let's say I want to change this 1 into a 0, I can access that first element, like in a tuple, it's 0 based index. So I can say list 0, like square bracket 0. That basically will mean I'm talking about the first element in my list. And if I want to set that to some value, I can do like this. You see now the first element in the list is 0. This is how you actually change an existing element in the list. This is adding to the end of the list. This is how you change a particular item or particular value inside the list at particular index. So this 0 is like you're basically this is 0, this is 1, this is 2, this is 3, this is 4, like that. Okay, it's getting a little bit more complex as we go, right? It's gonna get more complex, but you need to know the basics very well. Okay, so the important thing is list contains a list of values. Okay, you can call some methods to change the contents of the list. Okay, append is one way of adding to the list. If you want to change an item in a list, you say list the index that you want to change it and then assign new value to it. Okay, so if I say list 0, 10, that list gets, the first item gets changed to 10. If I say list like say 0, 1, 2, 3, fourth item, which is the 5 right now, if I say 4 equal to 10, so that fourth item get changed to 10. Okay, does that make sense? Vaishna, are you clear? Any confusion so far? Now suppose if I wanted to so append adds to the end of the list, right? Suppose if I wanted to insert something in the front of the list, there's another method, list insert. Okay, insert, it takes in 3 arguments. Self you don't have to pass in because it's just a convention, so you always look at the rest of them. Index and then another object. So in the first, in wherever, when I wanted to insert at the beginning, the index that I want to insert is at the 0th index. Okay, so if I say insert 0 and I pass in, let's say, -1 in there, that's my value. Now my list becomes -1. Okay, so I added a -1 at the front. Okay, so insert 0 will add a value to the beginning. Append will add values to the end of the list. Okay, so insert is more than, it can be used to insert any item at any index, not just 0. So it's more flexible that way. So let's say, for example, I added just before the 6th, I would add, so 0, 1, 2, 3, 4, 5, and 6. So if I say 6 and say -7 or something, so it'll get added there. Okay, now I can delete an item from the list as well. So it's list dot pop. Okay, so if I wanted to delete that item that I just inserted at 6th place, I can say list pop 6. So this -7 that I added, it gets removed. You see that? So these are some of the methods that we can use to interact with the list, change the list. Okay. Okay, last thing that we're going to learn is that there's a handy way to iterate through the elements of a list. Okay, so suppose here I have a list. I printed out the list. So let's say I wanted to this new thing that we're going to learn is iterating through a list item. So it's called for, and this is a variable. Let's say for I in list 1. And now basically what this is doing is that I have a list of elements, right, in the list. For I means it's going to go through one by one, and I would be whatever. It doesn't have to be I, it can be A or B, which is a variable name that I'm giving. I can say item. So for item in list 1 means, so now I can have access to that item. So if I say print item, it's going to be the first one, second one, third one. It is basically a loop. So this block gets repeated for every single item in the list, and every time it loops, the item is actually the item in the list. Okay, so if I run this program, enter a number, let's say I put 1 2 3 4 5 and let's say 10 and -1. So my list would be at the end of this while loop, right, at the end of this while loop, I would have appended 1 2 3 4 5 10. So my list would contain 1 2 3 4 5 10, right, and then I'm going to iterate through my list and I'm going to print out 1 2 3 4 5 6 one by one. Okay, that's basically what's going to happen. You see, this is another way for repeating. It's called a for statement, that for comprehension, that you iterate through all the items in a list. This is an easy way of doing it. I could have done the same thing in a while loop in a different way, but this is just a handy way for you to iterate through all the items in a list. Okay, so the nice thing is I can do a lot more things with that item. I can say item plus 1. So instead of printing 1 2 3 4 5 10, I can do 2 3 4 5 6. Okay, I can do much more than that, like anything that I want. Basically I have access to that item in that list one by one, and whatever statements that I have gets executed for each item in the list. Okay. So we learned a lot of things. Functions and the scope of variables. Global we don't want to use, we use the main, so we don't have to deal with it. And then we learned about another type called tuple, and tuple is a way to combine a bunch of variables into one variable, right? So we can return, because functions can only return one object, and in this instance we are returning a tuple, so we can return multiple things. And list is similar to a tuple, right? Where a tuple, once you create it, you cannot change it, but with a list you can change it. You can keep adding to it and removing it, so it gives you a whole bunch of methods, right? Like append, insert, pop, stuff like that. Okay, and to iterate our items in a list, we can use this for comprehension, and we can iterate through the list.
But every time you make a any variable, you have to start it with def.
No, variable you can just have to name it like this.
So what will you always have to put def on?
Def is for functions. Okay, so just practice the list and tuples and the functions. Try actually in the next class we will do some practice on those. Okay, the list and tuples, so we get a feel for how we use them. Okay, just one example that I showed you is just getting a list of numbers, storing into a list. So we'll look at other use cases, and we'll write some practice programs. Okay, so then we'll be prepared for our next assignment tomorrow. Okay, any question? gets tired. Brain is tired. All right. So bye. Have a good evening.
Bye.
Bye.
Bye.